Dear friends, today we are doing an experiment to find out the refractive index of material of a prism. At first, we should know what refractive index is. In optics, a refractive index is a dimensionless number that gives indication of the light bending ability of the medium. And it also depends upon material and wavelength of the light. Next, we should know what a prism is. Geometrically, we could say that prism is a kind or a type of a polyhedron. In optics, prism is a transparent optical component that has flat surfaces which can refract light. This experiment has three steps. The first step is setting up of the spectrometer. The second step is finding out the angle of prism, and the third step is finding out angle of minimum deviation. Angle of prism is constant for a given angle. The theory of this experiment is same as that of the ID curve experiment. As a ray of light enters into a transparent material, the ray's direction gets deflected based on the entrance angle and the refractive index of the material and according to Snell's law. A beam passing through an object like prism is deflected twice, once entering and then again when exiting. The sum of these two deflections is called the angle of deviation. Angle of deviation depends upon the refractive index of the material, angle of incidence and angle of prism. There is an angle of incidence at which the sum of these two deflections is minimum. The angle of deviation at this point is called the angle of minimum deviation. At the minimum deviation angle, the incidence and exit angles of the ray are identical, and this is a consequence of the principle of time reversibility. Now we can go back to the experiment. The materials that we require for this experiment are
glass prism, spirit level, magnifying lens, then we need a spectrometer, and the light source is sodium vapor lamp. We are using sodium vapor lamp because sodium light is almost monochromatic, and this an incident ray will only undergo refraction. If we use a white light, a single incident beam will disperse into many colored beams, making it difficult to measure the angle of dispersion. This is the glass prism. These two faces that I'm holding, and this face is the rough surface or opaque face, and this face and the face opposite to this are the refracting faces of the prism. Light gets refracted at these two faces.
So now I'm gonna talk about the initial setups of this apparatus. This is the telescope, and take the spectrometer out and point its telescope on a distant object. Focus it on the object using the screw provided in the telescope till a very clear and well defined inverted image of the distant object is seen. Through this, we have to see the slit very clearly. So now this is the prism table, and this is the screw which can adjust its height. The spirit level is placed on the prism table in parallel to the line joining any two leveling screws. The air bubble in the spirit level is brought to the center by adjusting the two screws. Then it is placed in the particular direction, and the air bubble should brought at the center by adjusting the third screw. There are vernier scales visible on the two sides of the spectrometer, and this is the screw to adjust the movement of this thing. Now here comes the adjustment of collimator. The telescope is brought on line with the collimator. The slit is illuminated by a source of light. If the image of the slit appears blurred, then the screw of the collimator is adjusted until a clear image is seen when viewed through the telescope. Now the rays of light emerging from the collimator will be rendered parallel. Through this eyepiece, we have to make sure the slit is visible clearly. So this is our slit which can be seen through the collimator, and we should be able to see the slit through the telescope. Right after the slit is visible, tighten everything properly.
Now let us move on to finding the angle of the prism. The prism is mounted on the prism table such that the light emerging from the collimator should be made to incident on both the refracting surfaces of the prism. The rough surface should be faced towards the telescope. The yellow sodium light comes out of the collimator and are reflected through the smooth surfaces of the prism. Release the telescope, move on to position 1, and in the telescope we can observe the yellow slit. Then we will shift our telescope such that the crosswire is just above the yellow line. Similarly, set telescope in position 2, observe the slit. Now measure its readings. While taking a reading, always use the magnifying lens. We have two vernier scales in the spectrometer. Note down the readings of both verniers from both the positions. These are the values obtained from the observation.
Now we're going to find the minimum deviation angle. For that we have to find the direct reading first. So for that we're making the vernier scale reading as 0 and 180 degree for convenience. So let me adjust it. Now it is adjusted. I'm going to tighten the screw to fix this value. These are the vernier scale readings. Let's focus on the slit and align it with the crossbar, and we need to make sure that the prism is clean before doing the experiment. Now we're going to find the angle of minimum deviation. So this is the rough surface and the other two are the refracting surfaces. We have to place the prism in such a way that the light emerging from the collimator incidents on one of the refracting base of the prism. Let me place the prism like this. Now the light incidents on the prism and it gets refracted. Or else previously we have kept the rough surface facing the right side. Now I'm placing it facing the left side. Now also the light gets incidence on the prism and it gets refracted. Let me place the prism like this and check whether I'm able to get the image of the slit. The light from collimator incidents on the prism and it gets refracted through this path. Okay. So here at this position we have got the slit. Let me slightly rotate the prism table. Okay, now the slit has started to retrace its original path. This is the point at which the slit has started to retrace its original path. Let us rotate the prism table slightly in such a way that the image moves towards the directory. At a particular position, it retraces its original path. I'm moving it in both directions to find at which direction the path gets retraced. So the previous, it didn't get retraced. So now at this point, the light has started to retrace its original path. So that point at which the light has started to retrace its original path is the angle of minimum deviation. It gives the angle of minimum deviation. We have got the point at which the light has started to retrace the path, and now I'm gonna take the reading of that point.
Coming to calculation part, this is the tabular column to find the angle of the prism. And these are the readings obtained from the experiment. Here, the difference between RA and RB gives twice the angle of the prism. And after dividing it by 2, we will get the angle of the prism A. In this observation, 215.65 minus 96.23 gives 119.42 degree. Halving, we will get 59.71 degree. Find the same for the rest of the readings. Then take mean of all these readings to get an accurate value of angle of the prism. Here the value is 59.53 degree. This is the obtained angle of the prism. Next, let us move on to finding the angle of minimum deviation. This is the tabular column and these are the readings obtained from the experiment. from both the vernier scale. The difference between R0 and RD gives us the angle of minimum deviation. Here R0 is 172.7 degree and RD is 119.1167 degree. The difference between these two is 53.2833 degree. Repeat the same for the rest of the readings for more accuracy. Now we will take mean of all these readings and mean value is 52.514 degree. This is the obtained value of angle of minimum deviation. Now we have calculated the angle of prism and angle of minimum deviation. Using these values, we will find the refractive index of the material of the given prism. For that, we have the formula refractive index mu is equal to sine of a plus delta m by 2 divided by sine of a by 2. By substituting obtained values, we get sine of 59.53 plus 52.514 divided by 2 by sine of 59.53 by 2. By calculating, we will get refractive index of the prism 1.67. Finally, from this experiment, we can conclude that the angle of the prism A is 59.53 degree, the angle of minimum deviation is 52.514 degree, and the refractive index of the material of the given prism is 1.67.